This is GCSEphysics Unit5, Podcast 1, Forces and Friction. So the first little bit here is just about what a force is and what it does. So forces are pushes, pulls or twists, and you learnt that in Year 9. And what do forces do? They cause a change whenever they act. So they cause a change in speed of an object, the direction of an object. So they can cause it to change direction. They can cause a change in size of an object. And I suppose the last one really goes with that. They cause a change in the shape of an object. So they cause a change in speed, direction, size and shape. So the next little bit says, say if the following are pushes, pulls or twists. So we've said they are pushes, pulls or twists. So writing on paper. So whenever you write on paper, what do you have to do? You have to push down on the paper. So writing on paper is a push. Typing on a keyboard, again, you're pushing on the keys. A tug of war, you're in one team, you're opposing another team, and you're trying to pull the rope over a certain point. Unscrewing the top of a bottle involves a push and a pull. So it's a push with this finger and a pull with that finger, and so therefore it's a combination of both, which is a twist. Posting a letter through a door, you are pushing the letter. Putting on a pair of socks, you are pulling them on. And turning a door handle, and we'd presume that it is a round door handle like that there, you're twisting. If it's a door handle, which is like one of the door handles in our school, where you have a lever and you push down on it. So it depends on the type of door handle. Right, types of force you need to know. And these are very common types that you would mention in everyday life. Friction, magnetism between two magnetic materials or magnets, nuclear force found in the nucleus, gravity, air resistance, tension. Tension acts in a rope or some kind of solid object where there are two things pulling it apart. Electrostatic force, which acts between two charged objects. And the last one you can't really see down here is compression. Now, compression is the opposite of tension, where you are pushing together two things or pushing together an object, and that's compression. Describing the forces. Now, we've got 4 descriptions and 4 forces here, and we're just going to try and match them up. So magnetism, you know, is to do with the poles of a magnet, and so it's a force that you get, and I'm afraid it's on the next page, I'm just realising. So what we'll do is we'll label them 1, 2, 3, 4, 5, number 2, number 3, number 4. Okay, so no, I see it is actually on this page. So here we have 4 different forces and 4 different descriptions, and what you have to do is match them up. So the first one is magnetism, and magnetism is force that enables compasses to work, and this is the one down at the bottom here. The next one is friction. And friction, you know, is a force which opposes the motion of an object, or it's a force you get whenever you have two materials rubbing together. And so you can see that description up here. So this is just this one here. The next one is compression, and we said that compression will happen whenever you have objects which are being squeezed together. And so this is the force you get when a material is being squashed. And the last one then that we have here is tension, and obviously it's the one that hasn't been identified here. The force you get when a material is being stretched. And those are your 4 forces on this page. Okay, the next set of forces are gravity, nuclear, air resistance and electrostatic. So we'll label them number 5, 6, 7 and 8. So the first one is gravity. Now we know that's gravity that exists between all objects with a mass. And so that's this one here. You might have described it as a force between the Earth and objects on the Earth's surface. The nuclear force is a force which acts in the nucleus, which holds the particles of a nucleus together. So this is this first one, the force that holds the particles in a nucleus together. The next one, air resistance, is a force you get when an object moves through the air. And the last one is electrostatic force. And electrostatic force is a force you get between two charged objects, a positive and a negative charge, or a positive and a positive, or a negative and a negative. Now, are they attractive or repulsive? Well, gravity is always an attractive force. It always acts between two objects. Unless the objects are really massive like the Earth, then you don't really see that force. There's a force, an attractive force, gravity force between you and your book, for example. But you won't see that force unless one of those objects is absolutely massive like the Earth. And that's why we just see all objects being pulled towards the Earth's surface. So gravity is always an attractive force. Magnetism can be both attractive or repulsive. So you know you get an attractive force when you have a plus, a north pole and a south pole. And then it's repulsive whenever you have a north and a north, or a south and a south pole. That's when it's repulsive. Electrostatic, which is the mistake I made just above there, of course acts whenever you have positive and negative charges, and it could be attractive or it could be repulsive. It is of course attractive when you have a plus and a minus, and it's repulsive when you have a plus and a plus close by, or a minus and a minus. Okay, another way we can describe forces is as being either contact or non-contact. If two objects or materials need to be touching for the force to have an effect, then it is a contact force. And examples of that would be things like friction, a push, if you're pushing something, you're touching it, a pull, a twist, air resistance, because you have contact between the air and the object which is moving. Then if two objects or materials do not need to be in contact for the force to have an effect, then it's said to be a non-contact force. And examples of that would be things like magnetism. So you know that magnetism can act between two magnets which are a short distance from each other. Electrostatic, again, you can attract things, light objects usually, to something which is charged. Gravity, of course, it isn't a contact force. The nuclear force. I suppose we should say up here that tension and compression are contact forces.